Welcome back, Munchers. Today we're going to take what we know about code and apply it to time and space complexity. Let's get started. Last time we discussed time and space complexity analysis, we mentioned two important points. One was that we have to examine the worst case scenario, and the other was that we analyze these two areas based on input. Well, the best way to understand this topic is to go through some examples first, then discuss them in theory. Let's say we have a function that swaps two strings. We take in a string word1 and a string word2. We don't return anything, so the function is void. To swap the strings, we put word1's string into a temporary variable to hold word1's value. Then we overwrite word1 by setting it equal to word2's value. Finally, we set word2's value to equal word1's old value, which is now stored in the temporary variable. What does this mean in terms of time and space? In general, we can consider a simple variable to contain 1 unit of space. Since there are 3 variables in this function, it takes 3 units of space. Similarly, we consider each simple statement to run in 1 unit of time. Since we see 3 statements here, we can say this function takes 3 units of time. You might notice, no matter which string is inputted in this function, you will always take 3 units of time and 3 units of space. This never changes, so we call this constant space and constant time. Let's take another example. Say we want to multiply a number by 5 an n number of times. If we wanted to multiply 3 by 5 6 times, for example, 3 would be the number and n would be 6. Therefore, as input, we pass in an integer x and the value n, and return an integer which would be the result. Then, using a simple for loop from 0 to n, we can multiply x by 5. Finally, we return x. What does this mean in terms of time and space? Space is constant, just like before. We have 2 variables. Time, however, is a little more complicated. We run only one statement, x equals x times 5. However, that statement runs in a loop n times. This means the time isn't constant. The larger the number n is, the more times the loop will run, which means the longer it will take the program to run. We can see this relationship is direct. If n increases by 1, the loop runs 1 more time, and so on. If we plot this on a graph, we can see that as the input increases, the time increases at the same rate in a line. Since we increase at a linear rate, we call this time complexity linear. Let's take a difficult problem that extends the previous example. Let's say we want to multiply a number by 7 an n number of times, but each time we do so, we want to subtract by 7 an n number of times as well before multiplying again. For example, if we wanted to multiply 3 by 7 twice, and in between, subtract 7 twice for each iteration, 3 would be the number and n would be 2. Therefore, as input, we pass in an integer x and int n and return an integer which would be the result. Then, using a simple for loop from 0 to n, we can multiply x by 7. Inside this for loop, however, we would add another for loop, which we call a nested for loop, since it's nested inside the first one. This for loop would also go from 0 to n, which now subtracts 7 from x before we go to the next multiplication. Finally, we return x. What about this one? What does this mean in terms of time and space? Space is constant just like before. We have 2 variables. For time, we run only 2 statements, x equals x times 7 and x equals x minus 7. However, these statements run in loops n times. The first statement runs exactly n times. The second statement runs n times inside the loop, but the nested for loop means the whole loop itself runs n times. This overall means the second statement runs for a total of n times n. Yes, that's quite annoying to say, but it should make sense the more you think about it. We can see then that the total time we have is n times n, which equals n squared plus n. This is a quadratic equation, so we say that the time complexity is quadratic. Looking at these examples, we can understand that we have various levels when we analyze time and space complexity. They can start at a constant value, where no matter what you do, the time and space will run in the same amount of time. But that can increase to a linear, quadratic, or even greater function, most of which we'll visit in future videos. We haven't seen this for space yet either, but be prepared because that will change soon. Lastly, I'll leave you with a final challenge problem. Drop the time complexity in the comments after attempting it. The problem is, if we have a function with two for loops, one goes from 0 to n, and the second goes from 0 to I, and it runs a simple statement inside. What is the time complexity of this function? Linear, quadratic, or constant? How do you know? I'll go over this in the next video, so don't worry if you can't find the solution. On that note, thanks for watching. If you liked what you saw here, give it a thumbs up, share it with your friends, subscribe, and hit the notification bell so that you know when the next one's coming. See you next time.